Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on writing formulas. So we'll go through and do ionic formulas, then molecular formulas, and then we'll put it all together. All right, so we have two types of compounds for which we can write formulas, ionic and molecular. When we write formulas, we start with the name. So the name will either be the name of a metal element or it'll have the name ammonium. And then the second part will either be a nonmetal or a polyatomic ion. If it's molecular, it'll only have metalloids and nonmetals. So we need to know where the metals and the nonmetals are. Our dividing line is boron, so we just draw this kind of straight line through here. And anything that is touching the line or to the right is a metalloid or a nonmetal, and anything to the left is a metal. All right, and then we're also, for ionic compounds, going to need to know the charges of things. So the charges of all of my main group elements I go over in the Introduction to Nomenclature video, but just so that we have it here, our transition metals all have varying charges, so we'll go over how it is that we know those charges in just a little bit. So 1 plus, 2 plus, skip everything in the middle, 3 plus, nothing, 3 minus, 2 minus, 1 minus, nothing. So for ionic compounds, we write the cation symbol and the charge. If there's a Roman numeral, then that tells us what our charge is, and we'll talk about that in a minute. And then we write the anion symbol and the charge. We know that it is a polyatomic ion if it ends in ITE or ATE. If it doesn't end in ITE or ATE, it's just the plain element, and I look to the periodic table and not the formula sheet. The exceptions to that are cyanide and hydroxide. Both polyatomic ions here end in IDE. Those are the only two that end in IDE. So if you're looking for these on the periodic table and you can't find them, flip back over to your formula sheet and you will find them there. All right. So once we've got our cation and anion charges, we look at the magnitude. So the magnitude is the number that is associated with that charge. So like a 2 plus has a magnitude of 2. So if they're the same magnitude, we cancel. If they're different magnitudes, we cross. All right. So what does that mean? When we cancel charges, that means that the cation charge and the anion charge are equal. So they add up to 0 automatically. So whenever we have an ionic compound, it has to be neutral, so the charges all have to add up to 0. If the magnitude is the same, then they're going to add up to 0 automatically. 1 plus and 1 minus equals 0, 2 plus and 2 minus equals 0, 3 plus 3 minus equals 0. So that means that you just cancel out the charges and then you just have one of each element. All right, so examples of this, sodium chloride. Sodium is Na with a +1 charge because it is in group 1. This ends in IDE, meaning it's the element, so that's the element chlorine. So this is in group 17, so it has a 1 minus charge. So 1 plus, 1 minus cancel, and I just have NaCl. You can also look here at magnesium oxide. Magnesium is Mg, it's in group 2, so it has a 2 plus charge. And it doesn't matter if you write +2 or 2 plus, like here I did +1 and here I did 1 minus. It makes 0 difference how you write it. Oxide is IDE. That means that it's the element version. So that means that it's oxygen, which is in group 16, so it's 2 minus. So 2 plus 2 minus cancels, and my formula here is just MgO. Right? Aluminum is Al, group 13, so it's a 3 plus. Phosphate ends in ATE, which means it is a polyatomic. All right, so if we look at our formula sheet, phosphate is PO4, and it has a 3 minus charge. 3 plus 3 minus cancel, and I am just left with AlPO4. All right. So if the charges are the same, so if the magnitude is the same number, then I just cancel out the charges, and then I just have one of each element, and I'm done. If the magnitudes are different, then I have to cross my charges. So the cation charge goes to the anion charge goes to the cation, and then I just cross out the plus and the minus signs that are left over. All right, so let's look at some examples of this. We'll start here with lithium sulfide. So lithium is Li, group 1, so it's 1 plus. Sulfide ends in IDE, which means it's an element. So it's a sulfur, it's group 16, it's a 2 minus. So 1 and 2 are not equal magnitudes. So I take the 1 from the lithium, I move it over here to the sulfur. I take the 2 from the sulfur, and I move it over here to the lithium. So I have Li2, S1. Protocol says that I don't need to put the 1 here if I just have 1. So the correct formula for this would be Li2S. If you leave the 1, it is not incorrect. You will still get full credit for it. Calcium hydroxide, calcium is Ca, it's in group 2, so it's a 2+. Hydroxide ends in IDE, but it is one of my exceptions, so this is polyatomic. If you try to find something that starts with hydroxy on the periodic table, you won't, so you just kind of flip it over and you see that hydroxide is a polyatomic ion with a 1- charge. 2 and 1 don't cancel, so I move the 2 from the calcium over to the hydroxide, and the 1 from the hydroxide comes over to the calcium. So this is Ca. And then because this is a polyatomic ion, I have to put it in parentheses. So the OH goes in parentheses and the 2 goes on the outside. So I can leave the 1 here with the calcium if I want to, or I can just do CaOH, parentheses 2. All right. Gallium is Ga, it's in group 13, so it has a 3+ charge. Oxalate ends in ATE, so it's a polyatomic ion. So I look at my formula sheet and see that its formula is C2O4 2-. These do not cancel, so my 3 comes over to here, and my 2 comes over to the gallium, and I have Ga2 parentheses C2O4 close parentheses 3. Because it's polyatomic ion and I have more than one, I have to put it in those parentheses. All right. If we're looking at transition metals, if you look at your element and you see that it is in group 3 through 12, it's a transition metal and it doesn't have a set charge. The charge is given to you in Roman numerals. So it'll have a Roman numeral behind it, and we just use that for the charge. A 1 is a +1, a 2 is a +2, a 3 is a +3, a 4 is a +4, 5 is a +5, and 6 is a +6. The exceptions to that are silver, zinc, and cadmium. They can only have these respective charges, so we don't use Roman numerals, but those 3 are on the formula sheet as well. So if you're trying to find the charges of any of these 3 things, flip to the formula sheet and it tells you that silver is a 1+, zinc is a 2+, and cadmium is also a 2+. Okay, so let's look at these examples here. Copper is a Cu, and it is a transition metal, and I know that because it gives me the charge here in parentheses, so that's a Roman numeral 2, so this is going to be a 2+. Sulfate ends in ATE, so it's polyatomic, and that's going to be SO4, and that charge is 2-. So 2+, 2- cancel, and my formula here is just CuSO4. So it's the same rules, it's just now instead of looking at the periodic table for the charge, we look at the Roman numerals. Iron is Fe, Roman numeral 3 means it's 3+. IDE means it is an element. So I'm looking for fluorine, which is F. It's in group 17, so it's a 1- charge. 3 + 1- don't cancel, so I cross. 3 comes over here, and 1 comes over here. So it's Fe1, F3, or just Fe, F3, right? And then tin is Sn, and I know that it has Roman numeral 4, so that's a 4+. Arsenate ends in ATE, so it's a polyatomic. And if I look at my formula sheet, I see that that is ASO4 3-. Those do not cancel. So again, I cross. The 4 from the Sn goes to the ASO4, and the 3 from the ASO4 goes to the Sn. Because ASO4 is a polyatomic ion, I have to put this into parentheses. SN3, ASO4, 4. All right, so that's how we do ionic compounds. Let's take a look at molecular compounds. Molecular compounds are super easy. You write the symbol for the element, and then behind it you put the subscript that corresponds to the prefix that is in front of the element. So it's just symbol, subscript from prefix, symbol, subscript from prefix, and that's it. Super easy. All right, so if we look here, I have trichlorine monoxide. Tri is 3, chlorine is Cl, mono is 1, oxide is oxygen. With molecular compounds, you don't have polyatomic ions, so the ending will always be IDE, so you don't even have to check. So that means it's Cl3O1 or just Cl3O. Next up, we have sulfur. There's no prefix, so that means that I just have one of them. Di is 2, bromide is bromine, which is Br. So I have S, Br, 2. Penta is 5, nitrogen is N, hepta is 7, phosphide is phosphorus, which is P. So this is N5P7. All right, so molecular compounds are, I'm not kidding, super easy. Okay, so what if you don't know if it's ionic or molecular? That is when we ask ourselves our two questions. Question 1, does it start with ammonium? So if the first word is ammonium, it is ionic. If it is not ammonium, then I go to my second question, which is, does it start with a metal? If the answer to that question is yes, it's ionic. If it's no, then it is molecular. Once you identify it as ionic or molecular, you use your appropriate rules. If it's ionic, you look at the charges and you either cancel or cross. If it's molecular, you look at the prefixes and you just write it as is. There's no crossing or canceling in molecular compounds. All right, so let's take a look at these. We have strontium arsenite. Strontium is not ammonium, but it is a metal, so this is ionic. And then strontium is Sr. It's in group 2, so it's a 2+. Arsenite ends in ITE, so it's polyatomic. And so the formula on my formula sheet says it's ASO3, 3-. These do not cancel, so I cross. 2 comes over here, 3 goes over there. SR3, because ASO3 is a polyatomic, I put it in parentheses, and I have 2. All right, next up I have dichlorine monoselenide. If you have prefixes, we automatically know that it's molecular, but you can go through your checklist. Chlorine is not ammonium, and chlorine is a nonmetal, so it's molecular. All right, so di is 2, chlorine is Cl, mono is 1, selenide is selenium, Se, so Cl2Se1, or just Cl2Se. So if you've got prefixes, you're good to go. Like, you just use those prefixes and you roll with it. Next, we have trisilicon pentanitride. This is the same situation. I have prefixes, which means it's molecular. If I look at my element here, silicon is not ammonium, and it is a metalloid, which means that it is molecular. Tri is 3, silicon is Si, penta is 5, and nitride is nitrogen. Si3, N5. All right, lead nitrite. Anytime that you have Roman numerals, it also means that it's going to be ionic, but we can kind of do our checklist here. Lead is not ammonium, but lead is a metal, so this is going to be ionic. Lead is Pb. This is Roman numeral 4, so this is going to be 4+. Nitrite is ITE, so it's polyatomic. If I check my formula sheet, it is NO2, 1-. 4+, 1- don't cancel, so I cross. 4 comes over here, 1 goes over here, and I have Pb1. The NO2 has to go in parentheses with the 4 on the outside. Because there's only one Pb, I don't have to put that 1 there. So this is just PbNO2 4, and I'm done. All right, so let's look at a couple more. Silver phosphate. Silver is not ammonium, but it is a metal, so this is ionic. Silver is a transition metal, but if I flip to the back of my formula sheet, it tells me that it's a +1. Phosphate is an ATE, so it's polyatomic, and that formula is PO4 3-. 1 and 3 don't cancel, so I move the 1 to the phosphate and the 3 to the silver. So here I have Ag3, PO4 1. If you put the 1, you do need the parentheses, but if you just have 1, then you don't have to put the parentheses. And you can just leave it as PO4. So this is just Ag3, PO4. Gallium sulfide. Gallium is not ammonium, but it is a metal, so this is going to be ionic. Gallium is in group 13, so it's 3+. Sulfide ends in IDE, so it's an element. Sulfur is in group 16, so it's 2-. Those do not cancel, so I cross. 3 comes to the sulfur, and the 2 goes to the gallium, and I have Ga2, S3. Next we have oxygen monofluoride. Oxygen is not ammonium, but it is a nonmetal, so this is going to be molecular. Oxygen is O, mono is 1, fluoride is F, so this is just OF1 or just OF. Barium thiosulfate. Barium is not ammonium, but it is a metal, so this is ionic. It is in group 2, so it has a 2+ charge. Thiosulfate ends in ATE, so it's polyatomic. And if I look at my formula sheet, its formula is S2O3 2-. 2 plus 2- cancel, so this is just Ba S2O3. All right, last two. Lithium is not ammonium, but it is a metal, so this is ionic. Lithium is in group 1, 1+. Dichromate ends in ATE, so it's polyatomic. That is Cr2O7 2-. Those do not cancel, so I cross. The 1 comes to the dichromate, and the 2 goes to the lithium. Li2 Cr2O7 1. If you don't want to put the 1, then you don't need to, and you don't need parentheses. Li2 Cr2O7. All right, last one, tetracarbon. Carbon is not ammonium, but it is a nonmetal, so this is going to be molecular. So tetra is 4, carbon is C, nana is 9, and fluorine is F. C4, F9. All right, so that is how we write formulas for ionic and molecular compounds. This has been another episode of Chemistry with Wikipedia Tutorial Edition. I hope you learned something, and until next time, keep on chemin'.